Everyone, just doing some vector component practice. What we're going to start by doing is just drawing in the x and y components on vectors. You'll see the example one is this middle one here, 9 pounds. So that's the hypotenuse, 9 pounds. And it's 20 degrees from the horizontal. The horizontal is the horizontal or flat line. So there's the 20 degrees, and there's AX and there's AY. Obviously, you can't do dotted, well, I can't do dotted lines easily on here, so I'm just going to keep them red and blue. All right, so this is 40 meters. And it's 40 degrees from the horizontal line. So think to yourself, is it 40 degrees from the vertical? That's the vertical line, or the horizontal line. Okay, so the 40 is going to go down here with the horizontal. That's what we mean by that. Now we know red is horizontal. So this is AX. And we know blue is vertical. AY. All right. Now, how do I know those point to the left? How do I know that one points up? Well, look at the main vector, the 40-meter vector, the resultant. Does that vector in terms of left and right, does it point more left or more left or more right? Hopefully you notice it points more left. So the x component is going to be pointing left. Look at that 40-meter vector again. Does it point more up or more down? You'd see the y component points up. So the y component has to point upward. Those arrowheads are not optional. Okay, you can't choose not to draw them, and you can't draw them the wrong way. Okay, they have to lead you from beginning to end. All right, so let's do this 20-kilometer one. So this is 20 kilometers and 15 degrees from the vertical. So this is 15 degrees, this little angle in here with respect to the vertical line. So there's our AY and our AX. All right, so next one here, 15 meters per second. And it's 50 degrees from the vertical. So again, this is the vertical, this is the horizontal. So it's 50 goes in here. That's where the 50 is. Now I do this a lot, so it kind of becomes second nature to me, but you might have to take a little bit of extra time to think about, okay, which way does it point? This points down AY because the vector is generally pointing downward, and AX points to the right because the vector is also pointing to the right, AX. All right, this is 45 newtons, and it's 70 degrees from the vertical. So this angle right here is going to be 70 degrees. Here's our vertical component, AY. Excuse me, I'm going to do that in blue. AY. And this is going to be our horizontal component, AX. All right, next one is 15 feet. And it's going to be 80 degrees from the horizontal. All right, so this is our 80 degrees here from the horizontal line, which is red. So this is AX. Our vertical component then brings us to the end, AY. If you're asking about this whole, oh, wait, I thought it was tip to tail. Well, the two vectors we're adding, the x and y component, are tip to tail. But the resultant, the tail of the first vector goes to the tip of the second vector. All right. This vector here only points in the y direction, so it only has a y component. This vector only points in the x direction, so it only has an x component. All right, this last one here is 30 degrees from the horizontal, so it's 100 meters per second. 30 degrees from the horizontal, so think, is that from here or from here? Where's the 30 degrees? Well, hopefully you know the horizontal one is that second one I drew. It's that top one I drew here. All right, so this is going to be our horizontal component, AX, and then our vertical component, AY. Now it says, using the angles given in the diagram, calculate the values of the AX and AY. Okay, great. So notice here for this one, we have 20 degrees and 9 pounds. So AX is a cosine theta, AY is a sine theta. You know, so we get the X and Y components. If you wanted to, you could write those in there. AX would be 8.46 pounds, and AY would be 3.08. I would recommend you do that for all years. I'm not going to do it just because it takes a lot more time. So let's look at the first one here. So for the first one, to get AX, we're going to do A times cosine theta. Watch out though. It's not 40 degrees. It's the angle with respect to the positive x-axis. So the angle we actually have to use is not 40 degrees, but 140 degrees. I know, it's a little bit tricky. So AX equals, let's see, 40 times cosine of 140. And AY, which I'll do in red, equals 40 sine of 140. Now, how do I know if my answers are right or in the same ballpark? Look at AX. AX better come back to be negative because it's pointing to the left. AY better come back to be positive because it's pointing up. Let's see if that's right. All right, so let's do that in our calculator. Let's see, so I have 40 cosine 140, and I get negative 30.6. And that's going to be in whatever that was, meters. And let's see, I'm going to have 40 40 sine 140. That's going to be 25.7. All right, and if you look down here, let's see, were those the answers? Yeah, they were. Perfect. All right, so we have the next one here. We have AX equals, let's see, 20 kilometers times the cosine of, watch out, it's the angle with respect to the positive x-axis. This is a bit challenging. So you have to think. It's 90, 180, plus another 75, so 255. I know it's a little tricky. Or you could do negative 105, but we'll do 255. All right, 255. So 20 cosine of 255 degrees. And the y component would be 20 sine of 255 degrees. Let's just see if that's right. I'm not going to calculate it, but let's see if that's right. Well, I know that the x component has to be negative because you'll notice here that it's pointed to the left, and so does the y component. They both have to be negative. So let's see if those end up being the right answers. Yeah, they do, and they both end up being negative. So there we have it. All right, let's check out this next one here. So this next one here is going to be 15 times cosine of, so we have 90, 180, 270 plus another 50. That's going to be 320 degrees. So 15 cosine 320. And the AY is going to be 15 sine of 320. And let's see if those were right. Yeah, they are. Now, what you could also do is make sure you could actually, instead of doing cosine of 320, you could do cosine of, or you can just use, instead of using 320, you can use negative 40 degrees. That'll be the same. And you kind of get the gist of it for doing the rest of these. These are challenging. Here's what I'll say. The ones that I definitely want to make sure you're able to do, like these are ones that like there's a good chance they pop up on the Regents exam or something similar. You should definitely know how to do anything that points upward. Okay. I know that makes it sound easy, but like these are the ones you should definitely know how to do. Ones that point upward. Okay. Now I do want to make a point talking about this one here, the bottom two. So if you look at the bottom left one, you'll notice it only points in the y direction and it points down. Okay. So for that one, you could use sine and cosine if you want. You could do like, cosine of 270, you'll get 0. And then sine of 270, you'll get negative 6. So it might be worth trying out, but I would definitely recommend you look at the answers to these and think about why they are what they are. Right? Again, these are extra practice. Definitely know how to do the ones I highlighted at the bare minimum. Okay. The other ones are definitely a little bit more challenging, but I do expect you to be a little familiar with. Okay. There are other ways to do this. If you're someone who's strong with trig, there are definitely other ways to do this, which I recommend you trying out. But again, bare minimum, know how to do these ones I highlighted. All right. Have a great day. Let me know if you have questions. And don't forget to also check out where we did this in class. I think it may have been class 32 where we did the vector components. All right. Have a great day, everybody.